This problem is an application of the Newton's second law of motion together with the equations of kinematics na napag-aralan natin sa previous lessons. In Newton's first law of motion, it explains what happens to an object that has no net force acting on it. The object either remains at rest, hindi gagalaw, or continues moving in a straight line with constant speed. While in second law of motion, it answers the question of what happens to an object that does have a net force acting on it. The acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Yung constant of proportionality is equal to 1, and if we are going to rewrite into mathematical terms, this is our formula for the second law of motion, where the A is the acceleration of the object, M is the mass, and summation of F is the vector sum of all forces acting on it, or the net force. Take note, kapag nagsisolve na tayo ng problems regarding Newton's second law of motion, yung direction na acceleration is in the direction of the net force acting on the object. Commonly, madalas nakakita natin and ginagamit ng physicists itong equation na to, derived equation, which is net force is equal to mass times acceleration na. So it has the relationship between the mass, acceleration, and the net force. The second law is a vector equation and equivalent to the following three component equations. So, horizontal component, vertical component, and kapag three-dimensional, may z component. When there is no net force on an object, yung acceleration is zero, which means the velocity is constant. Example number 1, the net force acting on an airplane has a magnitude of 1,900 newtons and points in the positive x direction. If the plane has a mass of 860 kilograms, what is its acceleration? In this problem, only the x components or the horizontal components are involved in the system. So we use the x component of Newton's second law. Summation of Fx or the net force at the horizontal component is equal to the mass times the acceleration at the horizontal. Solving for the acceleration, we divide both sides by the mass. So, we can cancel the mass, and acceleration na lang ang matitira. We have the summation of forces, or the net force, over the mass, and by substituting, ang net force natin is 1,900 newtons. Since isa lang naman yung force na nag-act, we have 1,900 newton over the mass na 860 kilograms. Now, take note that yung newton is equivalent to kilogram times meter per second square. And we have the mass here na naka-kilograms din, makakancel yung kilograms, and ang matitira lang is meters per second square. Therefore, by calculating, the acceleration is equal to 2.2 meters per second square. The plane accelerates in the positive x direction as expected, of course, and the magnitude of the acceleration is about 1/4 ng acceleration due to gravity. So this is example number 1. When we solve problems involving forces and the Newton's laws, it is very important to begin by making a sketch that indicates each and every external force, lahat ng forces na nag-act dun sa given object. And itong sketch nito is referred to as the free body diagram. In creating a free body diagram, there are several steps to follow. Number 1, sketch the forces. So we have to identify and sketch all the external forces na nag-act dun sa isang object. Sketching the forces roughly to scale ay makakatulong in estimating the direction and yung magnitude ng net force. Pangalawa, isolate the object of interest. So, i-replace natin yung object with a point particle of the same mass. Gagawin na lang natin siyang point para mas madali. And i-apply natin each of the forces acting on the object to that point or coming from that point. Number 3, choose a convenient coordinate system. any coordinate system will work in the problem kapag gagamit tayo ng free body diagram. However, if the object moves in a known direction, it is often convenient to pick that direction for one of the coordinate axes. Otherwise, magiging reasonable naman siya to choose a coordinate system that aligns with one or more of the forces acting on the object. Number 4, resolve the forces into components. So, we have to determine the components of each force in the free body diagram. Kasi hindi lahat ng forces ay nag-act only in the horizontal direction and in the vertical direction. Number 5, apply Newton's second law to each coordinate direction. Ito yung kapag nag-a-analyze tayo ng motion in each coordinate direction using the component form of the Newton's second law of motion. For example, we have this figure here. There is a sofa na tinutulak ng isang man. So, ang object of interest na tinatakal natin in this figure is yung sofa. So, we have 3 forces na nag-act dito sa sofa na to. Number 1, we have to sketch the forces. Unang force na nag-act sa sofa is yung kanyang bigat mismo or yung weight. So, yung weight niya is papaganyan. And of course, yung sofa na yan ay merong nararamdaman na force pabalik from the floor. So, meron ditong another force. Yung force na ibinibigay nung man, which is, say, eto siya. With an angle here, of course. Na-sketch na natin lahat ng forces na nag-act sa sofa. And number 2, we have to isolate the object of interest like in this figure. So, ginawa na lang natin siyang point. Ito na siya. And then, pinag-connect natin lahat ng forces with their respective direction. And number 3, we have to choose a convenient coordinate system. Say, ito siya. Ito yung y and the x para alam natin kung saan yung directions ng forces na nag-act dun sa object of interest natin. And step number 4, we have to resolve the forces into components. So, let's start with the n here. Yung n is nire-represent niya yung normal force na madidiscuss pa natin sa later lecture videos. Since pataas yung ating normal force, n sub x is equal to 0. And for n sub y, we have simply the n lang. For w, yung w is nire-represent niya yung weight ng sofa. Ang weight or ang w sub x is equal to 0. Ang w sub y or weight sub y is equal to negative w kasi pababa. And considering the positive y, ito is the positive direction. And for the f naman, say, nandito yung kanyang angle. For f sub x, this is f cosine theta. And for f sub y, this is negative f sine theta. Again, bakit naging negative? Kasi yung upward na y, ito yung positive direction. Since pababa ito, ayan siya. Ito yung f sub x and ito yung f sub y. Pababa yung f sub y. So, opposite sa positive direction. And for the 5th step, i-apply na yung second law of motion. 3 men, M, L, and C, push on a 752 kg boat that floats next to a dock. Each man exerts an 80.5 Newton force parallel to the dock. What is the acceleration of the boat if they all push in the same direction? So, in the figure, nakasketch na yung 3 relevant forces acting on the boat. We have force M, force L, and force C na nasa isang direction lang. Notice that we have chosen the positive x direction to the right in the direction that all 3 push. Therefore, lahat ng tatlong forces na yun have a positive x component. So, sa free body diagram, kung gagawin na natin siya ng free body diagram, so, ang object natin is yung boat, and ko-convert natin siya into a point. So, ayan. So, we have 3 forces na iisa lang ang direction. We have force M and force L and another force C. Alam natin yung mass ng boat and yung forces na nag-act sa kanya, and hence we can find the acceleration using the formula. Summation of forces or the net force at x, dahil ang ginamit natin is x component or the x direction, equals the mass times the acceleration due to x. And even though this problem is one-dimensional, it is important to think of it in terms of vector components. For example, kung i-add natin yung mga x components of the forces, we must be careful to use the appropriate signs, just as we always do when dealing with vectors. Yung force M is equal sa force L and another equal siya sa force C. They all have 80.5 Newton. So, lahat sila, tigi-tigi sa isang force lang ang in-exert nila dun sa boat at sabay-sabay nilang pinush yun. Ngayon, to solve for the net force, ipag-a-add natin lahat nung nasa free body diagram na yan. Since lahat sila ay nasa right direction, lahat sila positive. Solving for the net force, summation of f of x is equal to fm plus fl plus fc. And this is 80.5 plus 80.5 plus another 80.5. Summation of fx is equal to 241.5 Newton. And ito ngayon yung ilalagay natin dito sa summation of f of x sa formula natin to solve for the acceleration at the horizontal component, since alam naman na natin yung mass ng boat. Solving for the acceleration, we divide both sides by the mass. So we can cancel the mass ulit. Acceleration due to the horizontal component is equal to 241 as the net force, 0.5 Newton over the mass na 752 kilograms. And A sub x is equal to 241.5, this is kilogram times meters per second square over 752 kilograms. Maka-cancel ito. Ang matitira is yung unit ng acceleration. Acceleration due to horizontal component now is equal to 0.321 meters per second square. From the previous example natin, what are the magnitude and direction of the boat's acceleration if L and C push in the opposite direction to M's push? Nag-iba ng direction yung forces na na-exert ni L at saka ni C. Pakontra na sila doon kay M. So, hindi na sila equal lahat ng forces unlike sa previous example natin. I-create ulit natin yung free body diagram with the boat converted into a point. Si f of m natin is to the right. Considering positive ito. And this is f of m. And si f of l naman is to the left na, directly to the left. Same with f of c. Ito si f of c. Meaning, f of m now is equal to still positive 80.5 pa din. Si f of l naman is opposite to the positive direction. This is negative 80.5 Newton. F of c is equal to negative 80.5 Newton din. Solving for the net force acting on the boat, we have 80.5 kay f of m, ito yun, minus f of l, 80.5 Newton minus f of c minus 80.5 Newton. And the net force now is equal to negative 80.5 Newton. And ito na ngayon yung bagong value ng net force natin. And solving for the acceleration, net force over the mass, ang net force natin is negative 80.5 Newton over 752 kilograms. And the acceleration now is equal to negative 0.107 meters per second square. Kung mapapansin natin, naging negative na yung acceleration, ibig sabihin, naging to the left na yung motion ng boat. Si f of L tsaka si f of C, kasi si L at tsaka si C is nagtulak na dun sa left. Mas malaking forces na ibibigay ni L and C na papunta dun sa left. So obviously, sa left talaga pupunta yung boat. Take note that the method of using vector components and being careful about their signs gives the expected results in a simple situations like this, yung mga situation na ganito, and also works in more complicated situations where yung everyday experiences natin may be of a little help. So this is example number 3. This problem is an application of the Newton's second law of motion together with the equations of kinematics na napag-aralan natin sa previous lessons. In part A, to solve for the acceleration of the airboat, i-apply natin yung Newton's second law of motion. And for part B naman, only the resistance forces ang nag-act doon sa boat. Ito yung resistance forces na yan. So kapag yung boat is nasa tubig, of course, merong pumipigil sa kanya na forces, and yun yung resistance force ng tubig, which is pa-kontra, pa-ganyan. Only the resistance forces act on the boat in the x direction so that yung net acceleration can be found using an equation from kinematics. Then, gagamitin na natin yung Newton's second law of motion para makalculate yung resistance force. Let's start with letter A. We just simply use the Newton's second law. F is equal to mass times the acceleration, or simply net force. Nasa x direction yung lahat ng forces natin. So, this is x direction. We have a given net horizontal force which is 7.7 times 10 raised to 2 Newton. Yun yung ilalagay na natin dito dahil net na siya, net force na siya. Alam na rin natin yung mass which is 3.5 times 10 raised to 2 kilograms. We just solve for the acceleration. It is net force, horizontal, over the mass. And by substituting the numerical values, this is 7.7 times 10 raised to 2 Newton over the mass na 3.5 times 10 raised to 2 kilograms. Again, this is kilograms times meters per second square. So, makakancel ito. And ito yung matitira. Acceleration is equal to 2.2 meters per second square. So, this is the answer for letter A. And for letter B, gagamit tayo ng equation from kinematics. And the best equation to use is yung V square minus V sub O square equals 2A delta X, or the change in position. Since may position tayo na given, we have 50 meters. Yan yung final position niya. And meron tayong given na speed na 12 meters per second. Yung 12 meters per second na yan is the initial speed nung boat natin. Kasi sa letter B, after reaching the speed of 12 meters per second, panibagong motion na siya ulit. Nung nandun na siya sa 12 meters per second na velocity, panibagong motion na siya ulit. Siya na yung naging starting velocity. So, yung passenger daw ay nagpatay ng engine, and hinayaan na niya na mag-move yung boat niya hanggang sa makarating sa distance na 50 meters. Ibig sabihin, nag-stop na siya, so wala na tayong final velocity. This is 0 na, and this is initial velocity. So, we solve for the acceleration. Yung acceleration niya dito is naging deceleration na nung boat. Kasi from 12 meters per second na initial velocity, bumaba na ng bumaba yung velocity hanggang sa maging 0 na yung final velocity, nag-decelerate na yung boat. So, we solve for the acceleration. We divide both sides by 2 delta x. Cancel. A now is equal to negative V sub O square over 2 delta x. Ang V sub O natin is 12 meters per second. Negative, nasa labas yung negative. This is square. Over 2 times. Ang delta x natin is simply 50 meters na lang kasi x minus x sub O yan. Ang x sub O natin is 0. This is 50 meters. And by calculating, we will have a negative acceleration. Negative 1.44 meters per second square. Bakit naging negative? Kasi nga, deceleration na yung nangyari. To solve for the force resistance naman, or simply Fr na lang, F resist, ang ilagay natin, this is equal to MA pa din. Ang gagamitin natin na acceleration is yung deceleration, which is a value of negative 1.44 meters per second square to solve for the resisting force. Resisting force is equal to, ang mass pa din is the same. Yung boat pa rin ng object natin dito, this is 3.5 times 10 raised to 2 kilograms times the negative 1.44 meters per second square na acceleration. And by calculating, ang resisting force natin is equal to negative 504 Newton. Itong part na to, which is what we call the propeller, ay nag-exert ng force on the air, pushing it backwards behind the boat. Tinutulak niya yung boat para mag-move forward, and at the same time, yung air naman na nag-exert ng force on the propeller and consequently on the airboat. So this is example number 4.